The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the webinar, Planning for a Water Well. I'm Cliff Trines, Director of General Public Outreach for the National Groundwater Association. It is my privilege to introduce our presenter. Mark Layton is a certified well driller and certified pump installer with Kickapoo Drilling Company in Downs, Illinois. He is a member of the Illinois Association of Groundwater Professionals, and he also is a member of the National Groundwater Association. During the presentation, feel free to type questions in the question box. At the end of Mark's presentation, he will answer your questions. Also, at the end of the presentation, we will make a handout of the presentation available for downloading. This webinar is provided by the National Groundwater Association and the Rural Community Assistance Partnership with support from the U.S. Environmental Protection Agency. Without further delay, I'll turn it over to you, Mark.
Thank you, Cliff. Good to be here. Thanks to the RCAP and NGWA and the EPA for go ahead and putting on this Planning for a Water Well webinar. We'll go ahead and get started. There are many different reasons to drill your water well. We put on here just looking at that house in the country. You finally got that parcel of land that you've always been looking for, and now you got to figure out how you're going to go ahead and supply that house with drinkable, viable water supply. Or say that you've already got a well and it's finally gone bad. It's been there for 60 to 100 years and it's just no longer going to make it anymore. Now you have to go ahead and look at drilling another well at that point in time. Or more recently, when you're doing real estate transactions, you're buying and selling existing houses with existing wells and existing septic systems. A lot of times the banks are requiring to go through and do well inspections. And if that well is not up to code or not a good viable supply, they're requiring that you either upgrade that well or drill a new one at that point in time. In that case, and in all these cases, proper planning is going to be what is going to ensure that you have an adequate and viable and good quality supply for years to come. We're building something for the future when we put a water well down, and that's what we want to go ahead and make sure that we do it right from the start, because once it's there, you can't quite fix it. It's better to do it at the beginning than it is at the end. It helps to know where to start when you're looking at trying to get information on, say, the other water wells around the area. You have many different places to look at. You've got your local health departments in some states, either county or your counties or your individual health departments. Some counties or some states do it through their DNRs, which is your Department of Natural Resources. Some states have information on their geologic surveys. Here in Illinois, we have a very good state geologic survey that tracks a lot of water well information and puts that on some interesting mapping software so that we can go ahead and see kind of at a glance some of the different wells in the areas, and then we can actually kind of drill down into that information, look at what some of those depths are, what some of the geologic information is, even what some of the well production rates are, so that you have an idea on gallons per minute and what the water levels and things like that are of the existing wells. Your neighbors are a good source, but one thing that we always talk about as drillers is that your memory is never as good as a good record. So even if your neighbor swears up and down that their well is 100 feet deep and it makes more water than anybody's ever seen, it's a good idea, but you don't always trust it until you see the actual record or the actual individual who drilled it and what they have to say, because some people's memories are just not quite the best. But in lack of other resources, your neighbors are a good supply. And then, of course, you also have local water well professionals like me who have experience in your local area. You want to try to find the people that are pretty much as local as you can find for the area that you're working in, because they're the ones that do it every day. And you'll find that in water well drilling, we all kind of have our own little niche areas that we're very, very good at. A certain driller, a certain contractor, professional is going to have a certain area that he deals with every day, and then right next door to him, another contractor is going to have another area that's going to be where he likes to go ahead and work in. There's going to be overlap, but for the most part, your local contractor is going to be your best. You can also stack that in your favor by looking up to see if they're members of your local water well associations or professional associations, or if they're members of NGWA. If they are, then they're taking an extra step to go ahead and show their professionalism and be part of something a little bit better than just your local well guy. They're going to know also not only places to go ahead and place that well, but also, is there any contamination or anything to worry about? Do certain formations that they're going to pass through, do they have any type of interference or things that they need to case off to make sure, case off or block off, to make sure that unwanted waters, contaminated waters are not going to flow into what you're going to be drinking. That knowledge is very, very important. Actual location of your well is actually going to be determined by factors other than just straight geology. Your land surface, slopes and areas. You want to try to make sure that you try to stay on places where the water is going to slope away from the well itself. The reason for that is you don't want contamination to go down alongside of the casings all the way down and make it into the aquifer. There are some exceptions to this rule, though. There are places where instead of putting it at the top of the hill, we've had to put it at the bottom of the hill, or you've had to put it out there actually in the floodplain of the river or the creek that was down there, because that was actually the only place to find water. In those instances, yes, you need to work with a contractor. Yes, you need to work with your local regulatory agencies because there's usually some sort of either codes or acceptable practices on how to go ahead and construct that well to make sure that the cap and the lid is secure, that it's high enough above whatever that floodplain is going to be, to make sure that water can never get down inside of it. So there's always exceptions to every rule in that instance on that. But for the most part, you want to find a good place where everything's going to slope away, that's going to be out there where you can get access to it. You want to go ahead and you want to remember to plan your water supply before you're building of your house. You got to remember that it's easier to move your house than it is to move your well. And it's also, you don't want to get to the point in your house construction where you're putting up paint and carpet, getting ready to move in, and you have trouble finding a water supply. That's a very common occurrence for people that never thought that they were going to have an issue, that it's all your neighbors have plenty of good water supplies, plenty of good wells, and there's no reason why you wouldn't have yours. I drill in a spot where it's called glacial till. Basically what that is it's all the material that kind of came down from Canada, and all that material went ahead and kind of got bulldozed by all the individual glaciers, came on down through here, got all broken up, and so you have clays, you have sands and gravels, you have rocks, you have all sorts of things. As that material moved forward and back with the glaciers, then you had periods of time where the glaciers sat and you had rivers that ran across them, rivers that ran underneath of them, and then rivers that ran on the front of them. All those different mechanisms of moving water placed all that sand and gravel and all those water-bearing aquifers. But just like rivers nowadays, they don't run in straight lines. They go ahead and they curve and they meander around. And you can find places and sections where you can be surrounded by perfectly good wells and have almost a black hole where you cannot get water right in the middle of all of them. It can happen. That's where your contractor usually comes in and helps out quite a bit, knows what he's looking for, and sometimes we'll know where those spots are. Not always. You got to know that sometimes the reason that he's not found that is because he's not drilled in that particular spot before. But those are things that you could do, and you don't want to get as far as having your house pretty much done and not being able to find a water supply at that point in time. If you do, you could find that possibly the best place to go ahead and put it is in the front step. There's been situations where we've had a developer of a subdivision where he was putting in hundreds of lots. He went ahead and placed all the wells where he thought it was going to be the best, and one of them ended up right in the middle of the street that they were going to have to place. And there was no way to move the street at that point in time. The well had to actually be abandoned out, take everything out of it, go ahead and refill it with bentonite from the bottom all the way to the top, seal that well off, and then we went ahead and moved the well over into an actual lot so that it wasn't in the middle of the road. So these type of situations have happened in the past where without that proper planning, you end up with that well completely in a spot where you don't want to have that. So it's something to watch out for because it does actually happen. If you're seeking a replacement well, one where you're trying to go ahead and put a well back in a property that's already had a well, you are compounded because you already have infrastructure and other points of contamination. You may have things that weren't there when the well was drilled. Also, codes and things like that change every so many years to update for common practices. What you have in the old days, a lot of times you would come out the back door and you would go ahead and find out that you have your septic system, your water well, and your cistern back there all in different locations. And your cistern usually ran off rainwater off the gutters. A lot of times they used the water well for the farm, the cistern for the house, and the septic was all back there, all in the same location. When the well goes bad, current codes, and we'll talk about some distances and things like that later, but current codes will not allow me to put that water well back in the same spot because it's too close to that cistern, it's too close to that septic. But back in the 1940s, when all that stuff was placed there, they did not have those individual codes in place to state that you could not go ahead and place that well there. Now they do. So that's the point of contamination, and those are problems that now we have to go to a completely different yard and go to a completely different setup of how we're going to get water back from the new well into the existing setup and system. Where we just talked about that meeting the needs of those local authorities, that can be very difficult in trying to find that spot. There are some times that you have to place it too close to those materials, and that's where you need to go back and work with those local authorities, and it's always better to go and find them first, talk with them, make a relationship with them before the well is even drilled, in the permitting process, if there is a permitting process through that. And then if you start finding out that there's problems in how you can place the well or where the well can be placed, there are sometimes what they call variances, where you can go ahead and apply in writing to those local authorities and say, this is my problem, because I have a pig farm here and a cistern here and a septic there and a house there. The only place that I can put the well is right in the middle of all those, and there are so many distances apart from each other. If you do it in writing and there's no other place to go ahead and place that well, they will usually work with you, but sometimes they will go ahead and require water samples. Water samples are usually a good idea to take once a year anyways, because you're in charge, especially when you have your own well, you're in charge of making sure that it's a clean, viable supply. In a way where if you were in a city and you paid somebody else to do that, your water fees, you're now in charge and you pay yourself, in essence, to go ahead and make sure that everything is safe, clean, clear, and uncontaminated. A good water sample, once a year, is a good thing to take. Now, if you're doing a variance situation or something out of the ordinary where you can't meet all the local codes and that's the only place you could place a well, doing several of those in a row, usually indicated by two, about 30 days apart or so, and as long as they both come out clean, then you're usually okay, and most variance situations will be approved, and that well can stay there because it was proven that it's going to be an okay situation. Even though it does not meet code, it was still proven that it can be okay at that particular time. We also need to discuss, while we're talking about placement of your water well, we also need to discuss how much water that you're going to use. Sometimes that will indicate where you're not only where you're going to place it, but also how deep you're going to go, the type of formations that you're looking for when you get down to those depths, to make sure that you have the possibility of getting what you're looking for. When you're looking, you want to go ahead and figure out what your use is: drinking, cooking, laundry, dishwashing, your showers, things like that. That's your everyday use. That's the things that you're going to do every single day. Your seasonal use, which is your irrigation, watering your lawn, washing your car, filling your swimming pool. Do you have any of those? Special uses, crop irrigation, animal watering. I say high flow fixtures and things like that. The water treatment devices that require bag washing. Certain softening medias and things like that only require a ½ gallon a minute. Certain ones can require 7 to 10 gallons a minute. So you need to know that. Most standard houses, about 5 gallons a minute will usually do you okay, and you can set up a decent system. When you talk about more constant pressure type systems and things like that, which are your variable speed pumps, variable speed motors, those are going to be more in the range of 10 to 15 gallons per minute. Is what you're doing with those. You can go up from there. I've seen customers before that have gone ahead and they put in what I call a people wash. It was a 30 gallon a minute shower, which is a huge amount of water. When you consider that your standard faucet at home is going to flow something like 1.8 to 2 gallons a minute, you're talking like 15 of those run full blast. The problem that we had there was we could only get him like 23 gallons per minute was all we could get. And he asked us what he was going to do about a shower. We had to tell him that he had to take some of the shower heads out of the design. He was not going to have enough water to supply the shower the way that he wanted it. And that's back to in the planning stage of the house and the water well. It all works together like a jigsaw puzzle. Each piece has to work together to make sure that the plan comes together the way it should be. Conservative estimates for how much, because everybody always asks how much water do we use. Conservative estimates is about 75 gallons per person per day. Whether they're talking 2 to 4, family 2 or family 4, 150 to 300. That's a pretty good idea of about how much water that you're going to use. I think that people use a little bit less than that when they start thinking about it, but for the most part, when you go through it, how many times you flush a toilet throughout the day, use a sink, drink water, wash your dishes, wash your clothes, make cooking, and then you also got to remember if you do have softeners and other types of media there that go ahead and dump water down the drain, those are all within that estimate, how many gallons that you're going to need and how many gallons that you're going to use. What we're going to talk about next is your time frames that you're going to use those waters. Your bulk water within that short periods. 5 o'clock when everybody comes home, they go ahead and they can just hammer that water well because they're all using it all at the same time. Especially if you get into situations where you have multiple homes on a single well, as in subdivisions and things such as that. When you do that and everybody comes home all at the same time, they all go ahead and start cooking, they all go ahead and start cleaning all at the same time, and your water well may sit there and run for several hours at a time. It has to be able to meet that demand or meet that need. You get up in the morning, you usually take your shower at the same time. You come home at night, usually cook dinner at the same time. Those are kind of your peak demands and peak loads, and then throughout the day, it may not hardly get used at all. These are all things that we use for sizing up that proper water well, because we want to go through and make sure that you may not have to sit there and make sure that it can make, say, 30 gallons a minute or 20 gallons a minute or 15 gallons a minute all the time. But at particular times and particular instances, yes, you may have to produce that much to meet a short-term demand for those higher peak seasons or those higher peak uses. When we go through and we look at all those different factors, that's what's going to affect the well capacity to meet the water demands of the well. Flow rate. Flow rate is how much water the well is producing. That's usually measured in gallons per minute. That's what that is, and that's kind of a measurement of also what the formation itself is producing. If you have a rock formation or a sand and gravel formation, that flow rate is going to be basically what that water is being able to move or flow in gallons per minute through the ground into the well and then out of the pump. But that's what we're looking for, is flow rate of that well. Diameter and depth. That's going to determine the certain amount of storage within the well itself. If you do a 5-inch well, a standard 5-inch PVC well or a 5-inch steel well, it's going to be about a gallon per foot. If you do a 6-inch well, those are like 1.45 gallons per foot. By knowing that and the depth of the well, and then the next thing, the static water, that's going to allow us to figure out how much actual storage that you have. Storage is good where we talked about in those peak demands. If you can't get what you're looking for in the flow rate, if you have the storage to meet those peak demands, then the well can be a viable, proper one for you. Now, if you're trying to make the well work on just storage itself, you do not want to go ahead and try to do a whole lot of irrigation and other things. Irrigation is the thing where no matter what, you're going to turn that on, you're going to leave it on for a long-term period of time. And it's very rare to find a water well that is not capable, with the storage amount itself, capable of going ahead and doing full irrigation. If you want to do irrigation, your flow rate is going to have to be up there where it needs to be to match that demand for irrigation. I would not want to do an irrigation system on just storage capacity itself. Static water level. Static water level is going to be the level at which the water stands in the well when no water is being pumped. It's basically when the well itself is at rest, or when the water in the ground is at rest. It can be one of two things. It can be either what they call a water table. Water table is going to be where it fluctuates throughout the year. It's going to be high in the wet seasons and low in the dry seasons. Or you're also going to have what they consider to be an artesian. An artesian is where you actually have pressure. It's kind of like where your formation is down at 200 feet, but your water level comes all the way up to 12 feet. That's considered to be an artesian because the actual aquifer has pressure against it, and that pressure is going to push that static level up to a specific level where it's going to sit within that well or within that straw. That is your static level. That's where we talk about your storage capacity. Is in, say, a 5-inch well there, you would have 200 minus 12 would be how many gallons that you would have sitting there within your storage capacity to go ahead and be able to use properly. If you're a water table well, those are more like your dug wells or your very shallow drilled wells, in which your storage capacity on those is literally going to vary based on the seasons, and so is your static water level as to how much rain you've had within that. But if you get to an artesian well, you're going to work on different principles and different properties, and your storage capacity is going to be more standardized and more safe from those, more insulated from those individual periods of your droughts and your high water table type situations. We'll go ahead and get into some of the questions here, but actual location of the well often is determined by factors other than geology. We talked about this earlier there. That is true. Geology itself does not always factor in. In here it talks about land surface features such as slope, poorly drained areas are considerations of the location of the well. Yes, they are. All land features are considerations within the location of the well, as well as points of contamination, building processes, and other types of planning considerations. When planning a well for a home that is not yet built, the house location should be selected first, then the water well location. We talked about this earlier as well. That's a good way for you to end up with a house in your basement that wasn't supposed to be there, or in your garage where you park your cars, and lots of other things. Where we also talked about that most practices want that water well to be above ground. They're terminated above ground, meaning that the casing itself comes above ground. A lot of people like to think that they can go ahead and terminate in that casing or cap that well at ground level and put a driveway over it or put something around it and then they can access it, or try to put it into a pit. That used to be the way it was done back a long time ago. It is no longer the accepted practice. In my state, it's not allowed anymore to put a well underneath the ground, to put a well into a pit, or to terminate the well at ground level. You have to have that well 8 inches above grade, 8 inches above whatever the final grade is. That is where that well has to terminate to be code approved and a properly constructed well in my state. So that means that you cannot put it underneath your driveway, and you cannot put it in your garage, and you cannot put it in all these other places where you think that it would be a nice place to hide the well and get away from having to deal with it, or be able to build over the top of it. I've seen a lot of people try to put decks over them and things like that. Those, as long as it's still 8 inches above grade, yeah, you can get by with doing that. But at some point in time, and we're going to talk about this later on, you're going to have to work on it. So this is true. No, this is false. You want to go ahead that the water well needs to be selected before the house in most situations. The location of the well should be selected first to help ensure that the well is capable of producing an adequate supply of good quality water. The danger in selecting the house site first is that the spot chosen also could be the best place for a well adequate to meet the household water use needs. You want to make sure that you can move the house later in your planning process a whole lot easier than you can move where the well is going to end up being. That also goes with when you're looking at doing planning for a house. You're going to need a septic system, and you're going to need a heating cooling system. And a lot of times people are going with geothermal, which is either vertical or horizontal loops. In geothermal, you can move those loops basically wherever you want to, so they can move. Your septic, sometimes you can have it move, sometimes you can't. A lot of times I have to do specific testing to see what the soils are, and then the septic sometimes is locked into where it has to be based upon the drainage of your particular property, either the slope like we talked about, or the actual materials that the water is going to have to flow through to allow your septic system to work properly. So including where you're looking at moving your water well, you may also want to be talking with your septic contractor as to where he has to locate his, because you do have to keep enough distance between the two. So in the proper planning phase, yes, you do want to make sure that you put your well there before the house, but you also have to have some consideration at some point in time of where's your septic going to go. If you're doing a geothermal system, that's a little less critical as to where it's located. It still has to have a certain specific distance away from both your septic and your water well, but like I said, its location itself is not near as critical as your well, and then as your well and your septic at the same time. We talked about location of the well can be critical to water quality. If where nowadays you're not able to go ahead and put your septic system and your water well and your cistern and your pig farm right all next to each other. They don't let you do that. So you want to make sure that you locate that properly within all authorized specs and codes, and make sure that it's exactly where it's supposed to be. We talked there about whenever possible, you want to have a higher location, or basically you just want to go ahead and grade that ground away from your well. I've seen places where they had, in my particular instance, it was a bowling alley, and they kept getting bad samples and bad samples and bad samples. And we went and looked at the well, and it looked like that picture right there of the pour. Everything was sloped in right around the well, and not only that, they had 3 different gutters coming off the roof, dumping right into that area. So every time it rained, it filled up, and I do not believe it was a properly constructed well, and it was allowing contamination into the well every time that it rained, and that was why they kept getting bad samples. What we did in that instance there was we dug on down, we put in some bentonite layers, raised it, the casing up above, and made it look like that good picture. And then we removed the downspouts to different locations. And I believe in that instance we did finally get good samples at that point in time, but we had to do a lot of modification to that wellhead to go ahead and make sure that it was going to be an adequate supply, make sure that the potential for contamination from that runoff was not there, and not being able to go down that well. Okay. The well should be located so that it's easily excuse me, accessible for cleaning, repair, inspection, and other activities. This is the one thing in my industry that more and more we see. Everybody wants to go ahead and they want to hide the well in behind the house. They want to put it out in the backyard, someplace where they don't ever see it. You can't find it. You don't know where it's at. And it's out of sight, it's out of mind. It is a mechanical system, like your refrigerator, or your microwave, or your dishwasher. At some point in time, it's going to break. Whether it's your pump or your well or something in the wiring, something somewhere along that time frame is going to go ahead and it's going to break down on you. If it's behind your house or in a spot that is inaccessible, you're going to have problems in getting vehicles to it to work on it. And here's a drill rig, but just as an example, my service trucks they're much smaller than this, but they still weigh 16,000 pounds, which is 8 tons. Your normal pickup truck or car is going to weigh maybe somewhere top in 4,000 pounds, which is like 2 tons. So when you go through, and everybody always like, oh, it's not wet out there. I was able to go drive my pickup truck out there earlier today. Well, when I go and drive my bigger truck, which is basically 4 times as heavy as what you've been driving around out there, it's going to sink. It's going to get stuck. It's going to tear up your yard that you work so hard to put in, and it's going to cause all sorts of problems. And more than likely, either we're not going to be able to get to the well or not be able to get out of the well. And in that instance, you may go without water for a couple of days, and we can't get access to actually get a truck and pieces of equipment there to properly pick up and pull that well and work on it. These things are very heavy. Sometimes they're very, very deep, and you have to be able to get a truck to them. Sometimes you have to get a truck this size to them, which is closer to 50,000 pounds to be able to work on the well properly. It's rare to do that, but sometimes you may have to. Usually I like to go ahead and put them somewhere near the driveway. I don't want them so close that, say, a snowplow can come through and wipe them off, or a truck or something like that could back into them and hit them. So I want them about a vehicle length or more off that driveway. But I want them somewhere close enough that we don't have to try to get 5 or 6 or 7 truck lengths off that driveway to go ahead and get to that well where we can easily access that well for working on it. There are ways, if it is an issue where you don't like it in the front yard, you don't like it somewhere where it's accessible, there are what they call fiberglass mock rocks and other instances and things that can go ahead and easily hide those wells, cover them up so that therefore they match within the scenery. I've seen some that are so real that the bulldozer went through and thought it was a real rock and actually wiped it off and took the wellhead and cleaned it clean off with the ground. And we had to go back in and fix that because the bulldozer operator thought it was so real that it was a real rock. I've seen that happen. But there are ways to go ahead and make it where it blends in with some of the scenery. The other thing you want to remember when accessible is you don't want to go ahead and plant trees around it. I like to joke in my industry, in my area, that if I see you once every 10 years or so, every decade, once a decade, I'm basically doing my job right. In 20 years from now, that tree that you planted that was real small is going to be a big, big tree. It's going to need its limbs trimmed. It's going to need a lot of other work, and if we show up and we got to put a 40-foot mast up in the air to go ahead and work on this well, there's a lot of tree limbs that have to be taken out. You're going to have to get another contractor in there. It's going to take more time. It's going to take more cost. So you want to make sure that in your planning processes of what are you going to do with this well, where are you going to put it, and what are you going to put around it, that you do keep it accessible, not just for right now, but for 20 years down the line when we come on back to go work on it, that it's going to be able to put that mast in the air and get what we need to do to work on it, so that it does not cost you extra money or extra time and us waiting for those tree trimmers to come in there and take care of things. You got to remember, that's usually time that you're out of water, and you don't want to be out of water any longer than what you actually have to be. So proper planning can eliminate those, or can limit those downtimes to as little amount of time as possible. We talked about this, where the minimum distances and separation distances between wells and their contamination sources, where it talks about, in here it shows you the picture of the septic tank and the leach field. My particular state, which is Illinois, is usually 50 foot from the tank, 75 from that leach field. Now the gray area is kind of the area in between. Like, once it leaves the tank, is it considered the leach field, or is it still the tank? That's kind of the, well, so usually I just try to go ahead and stay the 75 away from the tank if I can. I just call it a complete system and just try to stay as much away the 75 or more away as possible. Where we talked about variances and things like that, where if you have to be closer and you've got no other avenue to put a well in anywhere else on the property, and you have to be closer than your local government's minimum distances, and you have to do that, do all that testing. I've seen that it works, and it can be okay to be less than those. But like I said, if your local governments and your state governments require minimum distances, you have to do everything you can to meet those distances first before you can ever even mess with those variances and things like that. And some places may not have them. Like I said, I talk where I'm from, Illinois, and I'm used to what I'm used to in this particular state. So that's kind of my variance process through this state. Other states I know are going to be completely different. And I just said that, unless other states or regulations prescribe more stringent standards. Basically, we have some other distances here where we talk about landfills, cesspools, anything that's going to receive raw sewage, 200 feet. That one there is your pit privies, filter beds, septic tanks, 50 feet. Outer boundaries of the roads, 20 feet. Drains off the pump house floor, 2 feet. Property boundaries, 5 feet. The reason for the 5 foot property line isn't so much to respect property lines. It's because when you go there to work, you're going to be moving around. You got a truck in the way. You've got equipment going. You got to lay down 20-foot pipes. You're going to just need room to work and to maneuver around all that spots and all that stuff. And to do that, that's where that 5 foot boundary really kind of comes in handy, is because it just allows you room to go ahead and do the job and do it properly, where you're not jumping on your neighbor's property every time to do that. Iron sewer and improved mechanical joints. You find that more where, say you're on the edge of a city and they have sewer lines running through your front yard, but you're still on a water well. If that happens, then if those mechanical joint and those iron sewers are all approved in the way that they're constructed, that well can be 10 feet from that sewer system, that actual city sewer system, if it is constructed of the proper joints. That's the one thing. You have to either have the records to show that, or you have to dig it up and see that it is approved on those joints if you do not have the records. Otherwise, you kind of go back to the 50 foot or even farther, some of the 200s, based upon what it is. In my particular state, they have a whole list of things. There's probably about 20 different things that's on the list, with all the different numbers as to how far away they are from lakes, how far away they are from your pit privies and your old latrines, all those different things. But they still have what they call primary potential and secondary potential routes and sources. Anything that's not on that list that they don't know about, they can say it's 200 feet if they want to. Basically, most things that are on the list cover 99% of everything, though. I've seen it rare that anything's ever been called a potential primary or potential secondary route, but they have it there for the instances in which they cannot classify something there that allows them to go ahead and say, yes, you must stay a certain number of feet away from this. Some additional guidelines on what the immediate area around that should be free of debris, dirt, chemicals, and other potential hazards. Right here, they're showing you that they've got a puddle of water with a 55-gallon drum resting in there, and you have no idea what's in that drum. And eventually, that drum is going to open up, and that contamination is going to leach in that water, and it's going to go into the ground. And if there's a water well around there, there's a possibility that it can take that water well as a route or a source all the way down to the ground and contaminate the aquifer. You also have to remember, when you're planning on these properties, are there existing wells, old wells, wells that have been there for hundreds of years? We see a lot of times that farmers can go ahead and they will tear down all the sheds and all the buildings on their farm, but they'll leave every well that they've ever had, because that's a good well and it might make water again someday and some point in time, but it's still there and they don't want to get rid of it because it's an investment. Well, the problem is that if you're not using those wells, a lot of times they fall in disrepair. They're not being updated, they're not being maintained, and those can be routes all the way down into the same aquifer that you're going to be drilling your new well into. So you want to make sure that you find those on your property. You get them sealed up properly, because you don't want to leave them there to be a route that you're going to be drinking that same water out of. You want to make sure that you find them and you get them taken care of, because you get a situation like this and you find it next to an existing well or buried out there next to an existing well that's got no maintenance, it's got nobody checking it, got nobody testing it, nobody taking care of it, and very quickly it can be a system where it can take care of, or it can affect you at some point in time down the line. Surface water should not interact with the well area. You don't want to have, where we talked about that sloping, you want the water to go ahead and run away from the wellhead, not pool and puddle towards the wellhead. So that's what we're showing here with this particular slide. Just don't let it interact. Don't let it get close. The newer wells have all been what they call pressure grouted, pressure sealed for the most part. That's been the required practice for, I would say, more than 20 years, is to go ahead and pressure grout. And what that means is that they run bentonite, which is a Wyoming clay that swells up all the way around that casing, all the way basically down too close to where the aquifer is, and seal that up. And as any groundwater or any type of moisture interacts with that bentonite swells up to about 12 times its original size, seals any cracks and voids, and doesn't allow moisture and water to go down along the outside of that well. The old days, all they ever did was they shoveled what they called cuttings, which is the actual excavated materials. They shovel those back in there, and those sometimes can be quite porous. You never quite know. So if you let it slope towards the well, and you have a much, much, much older well, there's no way to know 100% which one you've got based upon the age and things like that as to how far back you go. But if you have an older well, there's a possibility that that water could be seeping itself down to the aquifer. You want to make sure that you slope that away from there so that that contamination does not have a chance to find a way down through by that casing and down to where it's going to be inside your well itself. Animals. Animals should be kept away from your wellhead. They have a tendency to like to go ahead and scratch up next to it. They can rip the wires out. They can rip the top off. Plus, they're going to go ahead and, in their natural thing of eating and their waste products, they're going to put that all around where your well's at. Usually, in my state, we say about, if it's pasture land, which pasture land is like your grazing areas, your big open grassy grazing areas, we usually say maybe about 10 feet from those. If you're in a what they call an animal confinement lot, an animal confinement is, I say, where they eat and where they go ahead and do their business. Very small area where they go ahead and that's their feed lots. Those areas, 50 feet is what we want to stay away from those. That's just my own personal state, my own personal, and our guidelines here for Illinois. But those are the areas that you want to stay away from because you want to keep the animals and your water supply away from each other. So it's back to proper planning, back to things where you want to go ahead and keep your water supply away from things that can contaminate it. The growth of the shrubs and things like that, you want to make sure that you can find your well, that you can see what's happened to it. You want to make sure that, too, as you're going around through there and mowing or taking care of it, that you're looking to make sure that your cap's still on, that conduit for the wire has not been broken. If somebody comes through there with a lawnmower and breaks all that or knocks any of that off of there, then it can be, then it can get contamination either through insects or through rodents and mice. There's some in cases we've had situations where they allowed the grass in a subdivision to grow up so high that you could not see the wells, and the big tractor lawnmowers that you sometimes see on the sides of the interstate going on down through there, and they would literally almost just take the top of the well completely off. And we had to go back through and fix a lot of those. And some of them did get insects, and some of them did get mice and other things living down inside them because the tops were basically knocked off, and no one knew no one knew they were knocked off for quite a while. I'm assuming that the people who did the lawn mowing didn't tell anybody, and that's why they weren't notified for a while. They didn't want to know that what they'd done. But those type of situations in real life do happen. So you want to make sure that your lid of your cap is on there and sealed, and that your conduit is nice and taken care of, and that it does not have a route to get into your cap where it can cause you contamination problems. You do not have to go this far with concrete around your well like this picture showing, but where it is sloped away from your well, that's kind of what they wanted to show, is that you've gone as far as to make sure that you sloped away so that any runoff cannot go down there. This is a good thing where it shows, you can't hardly see it there, but where it shows grout seal, in my state, they want it basically all the way down to about where the aquifer itself is, or a little bit above where that pump and that screen is. So that grout seal would extend all the way down up to the top, and then you want to make sure it's sloped away. And we would be 8 inches above grade at that point in time. Other questions to consider, important considerations, and the location of a drinking water well. At a higher elevation than the surrounding area, easily accessible for cleaning, repair, inspection, and other necessary activities. That's my personal favorite. Place where it's least noticeable, as close to the house as possible. A and B, or all of the above. I'm going to go with A and B on that one. A and B, locating a well at a higher elevation minimizes chance to flooding or pooling water around the wellhead, and easy access allows inspection, maintenance, and the importance to protecting the water qualities. In addition to state and local minimum separation requirements between a new well and potential contamination sources, the following are good general guidelines. 20 feet from the outer boundary of the road, 50 feet from a pretty filter bed, septic tank, tile sewer, or a foundation drain, 200 feet from a landfill, garbage dump, or cesspool receiving raw sewage, all the above, or A and B. I'm going to say all the above on these are usually pretty good guidelines and rules of thumb to stick with. All the above. Question. Any growth of weeds, trees, shrubs, or grasses within root systems within the 10 feet of the well should be removed. True or false? That would be true. And when they talk about root systems, those things I didn't talk about. But those roots do follow places where there's water, and if you were to ever get a leak underground, when you dig it up, you'll see exactly what I'm talking about. That those root systems basically will follow that leak and follow that water, and will go right towards it. So they can crack some materials depending on how big the roots are, And so the 10 feet, it's not a bad idea to do that. Like I said, also just to make sure that later on down the line, at some point in time, we got to work on it. And if there is trees and shrubs and flowers all planted right around that well, we're going to go ahead and we're basically going to have to stand on it and crush down whatever it is that is around there. So it can be as nice as it can be, but when you're out of water, it's not near as pretty because you got to have the water at that point in time. We talked about invading any crack or crevice within the well or surface below the ground. They're looking for water, and if there's a way to find a way into it, they will find a way into it. We're just about done here. This is talking about visit wellowner.org. You're going to find out more useful information and well owner tools, the private hotline, the tip sheets, online water well lessons, similar to what we have now in these live and recorded webinars. So you can come on back and you can hear us talk some more about some different things. And then don't forget to check wellowner.org for online lessons on what you should test your water for. We talked about that. The testing is a good idea to do, usually once a year, and you're the best one that's responsible for making sure that you have a clean, viable water supply. How do you maintain your well? Those are things as to what types of annual maintenance and things like that that you're looking for. How can I keep my water safe? Those are things that we just talked about here as to making sure that things are sloped away, things are tested, things are good and maintained, that you're looking for abandoned wells that are on the property that may not have been properly dealt with. What should you do if your well floods? That is very timely with what's happening now in Houston and what they're worried about maybe happening here in Florida. How do I get water treated? And then what do I need to know about my new well? Those are all things that wellowner.org has lessons that can help you answer some questions. And then we'd like to thank you for joining this webinar. It's put on by NGWA, by RCAP, and by the Environmental Protection Agency. So we'd like to thank you.
Okay, Mark, thank you for that excellent presentation. I'm going to switch, leave your slide up there, Mark. I'm going to switch it back to me so I can move those that handout into the handout box for people who want to download that. But I'm going to go ahead and ask a question that was posed by someone in the audience, and this has to do with testing. It says, when an existing well is close to a septic system and you pull a water sample, are you looking for E. coli, coliform bacteria, or both?
Usually both. When you're looking, the total coliform number is kind of an indicator of what possibly might be there. It's not an indicator that anything bad is there, it's just an indicator that something might be there. Your E. coli is your bad one. That one there, you're usually not going to find. On occasion you will. E. coli usually have a source of some sort, either a open cap or, like I said, the septic system that might be too close. That could be a source of E. coli if you find it. Total coliform itself is not going to be, I wouldn't jump up and down about it, even if it's in high numbers. They usually will give you, you really want it to be a number, not a pass-fail. Pass-fail tells you no idea of what, if anything, that they're going to go ahead. Pass-fail is not going to show you anything of what you're looking for. You want a number, and they usually give you what they call like a most probable number, anywhere from 0 to 200. And once they go above 200, they say it's too numerous to count at that point in time. If it's a low number of like, say, total coliform, and you have 0 E. coli, I don't worry about that so much. Just go ahead and reflush your system, inside, outside, all around. Kind of think of it like you're flushing fire hydrants in the city. Go inside and flush one faucet for a while, shut it off. Go flush another faucet for a while, shut it off. You want to try to hit all the different individual faucets throughout the house, inside, outside, and everywhere, flushing water through all that. And then go ahead and retest and see what you get at that point in time. If it's a high number, you probably want to go ahead and call up a contractor. And the reason I say a contractor on this one, a water well contractor, is because they're going to know the proper products to use. They're going to know the depth of the well, the water levels in the well, the amount of product to go ahead and treat that properly, to go ahead and give that a proper dose if you have a higher number. Usually I don't get too worried about a total coliform that doesn't have E. coli. If you ever want to get really scared, I always say wait until about August and go outside and test that water that's been sitting in your garden hose, the same one that when you were a kid you would pick up and you drink right out of your garden hose. Go out and test that and see how much total coliform actually comes out of that garden hose. And that'll scare you at that point in time, because you've been drinking out of that your entire life and you never once thought, that nice hot garden hose that's been laying there probably has got just as much or more bacteria in it than what you're seeing on your tests. But for the most part, I wouldn't worry about a low number. That's just reflushing. If you get a higher number, say higher than 10, something like that, then go ahead and call a contractor. Go ahead and see if you can't get that chlorinated at that point in time. Reflush the chlorine through the system, and then go ahead and retest. And then, like I said, I wouldn't be too worried about it. If you see an E. coli, then don't worry about your total coliform. With an E. coli count, you do have a source somewhere, something you got to look at. You didn't just get an E. coli out of the air. An E. coli is not a sample error problem. You got a source of E. coli, and you need to worry about that. If you get multiple E. coli samples, because you're too close to that septic system, then you probably got to move the well at that point in time. Seal up the old well and then move the well. It's possible that it could happen. I've had a few, not ones that are too close to a septic system, but ones I've had, I think, 2 in 20 years that we've ever had where we could not get them clean, where they would not get to the point of zero contamination. And we had actually one, we dug it up looking for sources all over the place. We dug it 12 feet down looking for reasons as to, was there cracks in the casing? Was there holes in that grout seal that we talked about on the outside of the well? Was there holes down into that could allow that contamination to go? We never could find any. We sealed up that old well, we drilled up a brand new well, and we got the system clean at that point in time. So there was some sort of source within that well. We never could find it. But in drilling a new well, we eliminated that source and was able to properly get them a good viable water supply.
All right, we got about 3 minutes left, so I got probably one more question for you, Mark. This has to do with storage and how much water somebody needs. The question is, what if my well cannot produce what my family needs? So let's say a well was drilled and it's just not producing enough in the storage of the well system itself. Are they out of luck, or are there some options for them?
There are some options. It kind of depends on how much that you're making, what you have in storage, and then how you want to do it. But there are ways to go ahead and put small to medium-sized tanks and things like that in your basements. And they have different things where, like, I don't remember. I think they're called like well minders, but what they do is they kind of monitor the amount of water in those tanks. And where we talked about peak demand, we're trying to get those tanks filled for those peak demands. And then on those non-peak demands, the well would sit there and slowly try to top off or refill those tanks. That's basically, there are systems that can do that. You try not to. 5 gallons a minute is usually kind of our bare minimum. We've done some down at 3 gallons a minute. And that one, we had to get in some special things to be able to do that. If you start to get less than that, you start to kind of, in modern days, you start to kind of worry a little bit about you. You notice that you don't have as much water as what you'd like. Same as electricity, same as everything in our lives. 60 years ago, we used a whole lot less. They had 50 amp power panels, then they had 100 amp power panels, and they had 200 amp power panels. Now I'm seeing in houses where they've got 600 amp power panels. We're using more electricity and more devices than we ever used before. Same as water. We're using more water and things like that than we ever used before. So you can get by with that. There isn't too much you can do to fix, say, a badly constructed well. If it's a good constructed well, there might be options to go in there and do rehabilitation to the well. That's something that you would have to find out with either the contractor who drilled it or a contractor who's very knowledgeable in your area. Like I said before, see if you can find one that's members of, like, your local associations, members of NGWA, ones that have made a little additional commitments and things like that. But if you can find those contractors that are knowledgeable on those things, they can look at your well and they can determine, is there rehabilitation that can be done to that well to try to make it make more gallons per minute? or is it a badly constructed well from the get-go, and this is the full amount that you're going to get, and there is no rehabilitation or anything that can be done to it to try to allow it to make more. And in that case, then you're either going to have to do some sort of tank system, or you would have to go ahead and try to just drill another well at that point in time.
Wow, that's good timing. It is exactly 1 hour. So with that, Mark, I want to thank you for an excellent presentation, and I want to thank everyone who tuned in today. We did put the handout or the presentation in the handout section on your panels there. If you didn't download it, you can always send me an email, and I can send it to you. My email address is T as in Tom, REYENS at ngwa.org. So with that, thank you everyone, and have a great day.